Without further ado, I'd love to welcome Wesley from Riot Games, and let's hear him talk all about how he uses Databricks and Spark at Riot Games. So let's give him a round of applause. Thanks.
Thank you. So, whoa, that's loud. Thanks everyone for attending. Today we're going to talk a little bit about how we have onboarded an additional 50 analysts onto Databricks and how we were able to do it without impacting the roadmap for our development team. So a little bit about me. I'm a principal data scientist at Riot Games working on League of Legends. I used to work at Google. I'm a boomerang for Riot Games, so I was here, I left, and I've come back. Previously I sent a lot of spam with ad knowledge. So I'm also, for those of you familiar with League of Legends, I'm a Leona support main, which means I dive in head first and don't think about any of the consequences. I'm excited to play Pike. And of course, the best Leona skin is Valkyrie Leona. A little bit more about me. So I'm actually in that little dot outside Rose Hill, Kansas is where I grew up. So if you take the entire population of my town, Rose Hill, it's probably about the same as the size of the number of attendees here. And so getting used to cities is still something that I struggle with every day. So for those of you not familiar with Riot Games, we are the developer and publisher of League of Legends. League of Legends is a multiplayer online battle arena where teams of 5 compete. So each player chooses from one over 130 champions. Each champion has unique skills, a unique backstory. They group up in teams of 5, so think of this like basketball, but set in a simulated environment with magic. So you compete with your team, you go for objectives, and ultimately try to win by destroying the other team's nexus. Players log in and play a couple games, maybe a night, so you can get through a couple sessions in about 40 minutes. We've been fortunate that our players have really loved our game, so we have over 100 million monthly active players of League of Legends, which is generating about 500 billion data points per day, and so far we've gathered roughly 32 petabytes of data. And so that gives you an idea of the scale of data that we're working with. And before I dive into sort of what we've done to onboard these analysts, I want to talk a little bit about the challenges that we face. So this is our current ingest architecture. We have different ways for players to interact with our ecosystem. So we have the game client itself, where players play games. We have a mobile app where players can log in and check their stats and do different things, talk with friends. And we have our web properties. So all of these generate events. Those events flow in through a public collector. But in addition to just those forward-facing events, we also have a lot of API backends. So this can be our legendary stats. It can be other APIs for matchmaking and those sorts of things. All of those events flow into a system we call Honu. Honu aggregates all this data. The event data flows in where it ends up at rest in S3. We run Hive on top of it to query. And that's sort of how we've interacted with our data up until the time we switched over to Databricks. Some of the challenges that we face with this. So this data system is Lossy and Schema List. So the Schema List choice was made because we want engineers to be able to develop and go quickly. So we don't want them to have to slow down and think about the other end of the people who are querying the data. This has had some impact on our ability to query the data, which I'll highlight in a little bit. So Lossy. So this was another design choice when we built the system. At the time, this was 4 years ago, we had big data. Everyone has big data. So rather than actually allow those event collectors to fall over, we decided that if they get too busy, they can just start dropping events on the floor. And so we maintain 99% of our data gets in, but that 1% that does get lost can cause some problems. It's also Schema List. So this is an event. Here we have an Orianna killing a Zed for first blood. This event generates a backend event that gets sent to our system. So here we have the app is legs, so that's our legendary stats service. And we have some useful things in here like the game ID, the killer, so which champion was killed and who they killed, the victim, and where on the map it took place. So it's a single static map. When the event happens, we record all of this information. And if you look closely at this, there's also some challenges here. So here we have some empty fields. So this event is actually shared between all game events. So sometimes a game event populates these, sometimes a game event doesn't. All of that is just tribal knowledge for us to have and make sure that we sort of understand when we should expect that data to appear. The other problem is that this is a flat map, so this is a map of string to string. So when developers want to send something a little more structured, they just go ahead and serialize JSON directly into it, which makes fun on the other side when you're actually trying to query the data and you actually have to parse all these JSON strings. So a little over 2 years ago, we rolled out Databricks for our data science team. And what it allowed us to do was we could replace Hive compute with Spark, which reduced our costs, actually allowed us to process things much more quickly. We used the notebooks functionality to iterate much more quickly on our data, so we could very quickly query, see what was there, iterate, and build products. We also use the REST APIs to sort of tailor the product to our needs. So it's not a perfect solution right out of the box, but you can actually make it everything you need it to be. And then lastly, scheduling. So our ETLs we work through. We have a lot of ETLs now scheduled on Databricks and running that way. This is a slide from an older talk. A couple years ago, we came and presented, and we found Databricks to be far faster, or Spark SQL, to be far faster than our EMR Hive clusters. I have not rerun these, but I assume that things have only gotten better for us. And so when we brought in Databricks, we actually launched a couple of products. The first one is a personalized offers. So this is a unique set of offers, 6 offers for every player in the world. They would log in, they click, they turn over. Each offer has a discount so that they can get skins at a discounted rate. And the experience that we're looking for here is we want players to be excited and delighted with what they get. So when they flip over that championship ribbon, they're like Vince McMahon here and super excited. We've also shipped year in review, so this one's much more data engineering product. So here, at the end of the year, we generate stats for every player to let them know how their year went with League of Legends. And so here you can see how many kills you had from Yasuo, how many deaths you had from him, sort of how well you did, and where you died and killed people in our map. We've done this now for the last 2 years, and it's been powered by Databricks. Now, I showed you our current ingest architecture, but there's a future architecture that's coming that I'm pretty excited for. And when we brought all these analysts onto Databricks, I didn't want to impact this roadmap. So this roadmap here, we're actually going to be deploying regional Kafka clusters with an item registry. So rather than sending schema-less events, we're actually going to have them have a proper schema, and schema evolution will be handled by the system. Those will go to a global Kafka clusters and actually sync into S3 via Databricks Delta. And everyone will be then querying the same data out of Databricks. And so this world I'm really excited for, and I can't wait until we have everything there. So the analysts and the way they interact with Databricks, they're after several things. So the first one they want to do is they want to build decks so that they can show leadership, sort of different things about our player base. For example, here we have the player health model. So how healthy our players are in the system, what does a healthy player look like, and how do we actively maintain more healthy players. They also build a lot of dashboards. So we have Tableau deployed and building hundreds of dashboards that get populated by our data from a data warehouse. They do ad hoc queries within Databricks, and lastly, they schedule their own ETLs. So we expect analysts to be able to do all of this themselves in a self-service manner. And so with all that set up, now I want to talk about some of the things we learned when we actually brought 50 additional analysts onto the platform. So the first thing that we actually sort of took away was we had a problem where engineers are not always consistent in their naming practices. So we have game details here, where we have a game ID, a player ID, how many kills, deaths, and assists they had in a game. But what we found was people were doing a lot of joins to another table, which was player stats. So game details is post-game, player stats is pre-game. So this was your MMR, your skill level before going into that game. And here we also have a game ID. You notice it's named slightly different. And we have an ID, which just happens to be the player ID. And so this sort of tribal knowledge of how to actually join these two tables was known by, or discovered by everyone who actually wrote a query and it broke. Then came along someone and was like, oh, I need store transactions. I want to look at what things they bought in the store and tie that up to how many games they've been playing. So here we have an account ID. So initial thought, and I actually did this, was to join that account ID to that player ID. But it turns out, nope. There's actually a store account table that has an account ID that's a different account ID that you have to map to first in order to get to the ID. And so that broke for the first personalized offers we ever ran, which was unfortunate. And so you can see that our data is in no way clean. But what we wanted to do was standardize that so that everyone was querying off of similar tables and this tribal knowledge could really go away. And so we've created several omnibus tables that actually do all of these joins for us ahead of time, so that when you're actually running your query, you don't have to think about all these underlying details that are gross to deal with. And so here you actually have things named in a consistent way, in a standard way, so that everyone understands what's going on. Be willing to experiment. So we've tried a lot of different things. So this is a well-known quote by Reid Hoffman, founder of LinkedIn. We tried many things that failed when we were first rolling out Databricks. And I don't look at all of them as sort of mistakes that we should be ashamed of, but things that we tried that just didn't work. And one of them was we chose for this omnibus, the first run of it, we chose to do it in ORC file format because we were eager to be backwards compatible with our existing Hive infrastructure. Well, it turns out that that format of ORC wasn't actually compatible with our backwards Hive system. So we wrote all this data for the last couple of years and then slowly encountered more errors where there was problems deep in Spark where it wasn't releasing connections properly for ORC files. And so we eventually just gave up on ORC and switched everything over to Parquet as it's becoming much more of a first-class citizen in Spark, and had to rewrite all that data. And I've done it multiple times with multiple tables where we actually just have to re-backfill everything. But that willingness to experiment and try things and fail is important for us to actually be able to bring on all these additional analysts. So this is Thomas Huxley. He is known as Darwin's Bulldog because Darwin didn't want to be in the limelight when he actually published his book on evolution. But Huxley was happy to go out and argue on his behalf. So when I say find a champion, we have Omid Rameshni, who is now my bulldog. So he's a director of insights, and he actually went out and told the analysts that they're going to encounter a bit of pain in the transition because no one likes to change, but they will be much better off after they do it. And so we found he was able to help us bring on all these people and make sure that they made that conversion and took the time to learn the new system and how to interact with it. And it's worked very well for us. Fix root causes. So when I started working with Databricks, I was joking earlier with Miles about this on how I'm one of the loudest complainers probably in the Databricks Slack channels and tickets. And ultimately what I heard a lot was, well, have you tried increasing the size of your cluster? That'll fix your problem. And I have rejected this every time that I've heard it, and I recommend everyone reject it. I come from the days of MapReduce where you could process a couple terabytes of data on 2 machines. It just took a lot longer. And so Spark has had some memory issues where it has these problems where you do have to increase the size of the cluster often. But I really want to make sure that that is the root cause before we actually just throw money at the problem. And so I've tried to encourage this in all of the analysts that's come on board because oftentimes they are all on shared compute. So we have 50 people on one big cluster and they break shit all the time. And so half the time we have to figure out what they did wrong, how they did it wrong, and how we can sort of prevent it from happening again. And we try to instill that in all of them rather than just throw more money at the problem. So be unblockable. This is a picture of the unified analytics platform. As I mentioned earlier, there was things that it did well right out of the gate, and then some things we had to sort of add in ourselves. And so we've added more pieces on top of the platform so that we can actually do more things. For instance, we have an ETL tool that was written that allows us to schedule jobs in all of our different regions. So we have 17-ish regions, which are separate, basically shards for players to play on. So LATAM, Latin America, we have Russia, Europe. So all of these, we run the same sort of ETLs on all of them, but we schedule them slightly different. And when LATAM is behind, because whatever reason the database is just behind on moving the data over, we want to make sure not to delay all the other processing for all the other regions. And so we built just a lightweight tool that sits on top of Databricks and decides to schedule jobs when data is ready. And so it just monitors the data and fires off jobs when it's done. We also have a Slack bot that allows us to query and check. I mentioned that we had 50 analysts on a shared compute. They break stuff a lot, so we often have to check what is the status of the cluster. And we can do all of this now via a Slack bot that you can actually query the status. It tries to run some code to see if it works, and you can even restart the cluster when they've broken things too bad. And Vinko here in the front row is the one who has been writing all of that. This icon is for Clash, so we have a tournament system where players can sign up and compete in a tournament, a weekend-long tournament. And we were able to leverage Databricks, and our data science team was actually building skill prediction. So we want to make sure that matches are fair and that tournaments are, you're not placing some of the best in the world against some of the worst in the world. You want to have matches that are competitive. And so we do skill estimation. And with Databricks, we were able to train the models offline and then deploy them and be ready for hundreds of thousands of players on day one. And then lastly, I've mentioned, or last year when I spoke about toxicity in chat, we do a lot of detection of sort of bad behavior in game through Databricks, and we're able to launch that into the REST services in separate models. So the last one here is we want to make sure that we foster a community. So we had 50 different people come on. None of them had any experience with anything other than just Hive SQL. So they only wanted to really write SQL. They didn't understand this whole new paradigm of programming. And so we actually built up a community within Slack where people would respond and help each other out rather than having to all be relayed through me. So I mentioned that in the abstract for this talk that we did it with a support team of 1, but in fact there was a lot of people in that Slack channel who helped each other out. We also encourage people to go as deep as they want to go. So of course Spark is open source. When things break, we encourage them to dig into the source code and figure out why it broke, if there's a way that we can fix it, and if there's a way we can prevent it. And we've seen some great growth from our analysts and engineers on sort of how deep they want to go and how far into the woods they want to get. Yeah, that is basically it. Thank you guys for your attention. We've got about 10 minutes for questions. Yeah, thank you.
Awesome. Thank you so much, Wes. Yeah, so if anyone has any questions, feel free, just raise your hand and I'll swing over with the mic.
So can you talk more about your toxicity detection system? So I guess it's 2 parts. One thing is like, what's the algorithm like? So is it just like a keyword search? And the other question is, do you do like a streaming job or do you just do like a batch process every like couple days or something?
Yeah, so we have deployed several different models, but the one we found worked best was a logistic regression over sort of the text. And it's scored by basically an API, a REST service call after each game. And then we decide whether or not we're going to punish based on that.
Can you talk more about the Slack bot you put for check the
Yeah.
cluster health?
So Vinko wanted to experiment with the Slack bot, and so he started building basically a little service that is connected to Spark via the REST APIs. And we can actually, when we can query a cluster, so given a cluster name, it'll actually try to run a small bit of code, just 1 + 1 on it, to see how fast it runs. If it comes back in too slow of time, then something's wrong with the cluster. And typically for us, that means that someone has ran a query without specifying any partitions, which leads to hanging of the cluster because there's only one, there's a lock on the Hive metastore. And so oftentimes we can actually detect that and then just restart if need be. And so the command, there's a couple commands. One is sort of query it to see if it's alive, and then restart.
All right. Any other questions?
You said you guys were using Tableau business intelligence tool. Do you guys plug that straight into Databricks, or do you go through a traditional data warehouse?
So we plug it, we're split. So we have Vertica as well. And so half of Tableau reports will probably run off Vertica, and we're slowly migrating more and more over to Databricks. So we have a dedicated cluster that is just serving Tableau requests as for all the ETLs or for the batch that they want to do.
Do you use data science on eSports for the professional scene?
Our team there is much smaller. We want to do more there. I think there's a lot more that we can do. So right now, we're looking at ways in which we can engage with them to sort of help fill that in.
My other question was, do you use data science for balancing heroes?
We help. So the analysts do a lot more of the sort of analysis of just how balanced a champion feels. There are opportunities where we're actually going to start digging in much more closely to the time series data. So look how a game unfolds so that we can actually tell sort of when the champion's broken and not have to wait as long to get that analysis. Yeah, that's overpowered. Yep.
Hi. Have you noticed a difference in the relationship and the communication between the analysts and the engineers after implementing this?
It's a really good question, and we have. So it's been really nice. Our engineering team historically has not gotten onto the data side. So I mentioned we allow them to move very quickly, and they would just send data off and not really care about where it ended up. As we have rolled out Databricks, they've requested more and more of our engineering team has been requesting access. And so they're actually coming in and trying to query their own data, which helps clean it up much more quickly because they realize they're sending shitty data and they need to do something to make it better. And so the interaction between our analysts and our engineers has actually gotten a lot better. They're communicating much more. They understand each other's problems better as well.
Hi, do you have any data science applying to the user player activity in game, like in-game AFK or smurfing, those kind of activities?
Yeah, so we do a lot of work where we actually detect not AFK but intentional feeders, so people who just run it down middle and die all the time. And the key there is we have to sort of figure out intent. So there's a bad player who may just die a lot, and then there's a player who is intentionally sort of giving up on the game. And teasing that out has been challenging, but we're not doing terrible at it. We also, to your other question about smurfing, we're doing some new work, especially with tournaments, where we're trying to get better at detecting smurfs so that we can ensure that a platinum player is not trying to get into a bronze tournament. And dominate the game. So yeah, we're actively investigating many of those areas. Mm-hmm.
You have a user reporting system for these things as well, right?
Yep.
So how do you combine the user feedback with the data that you get from the games?
It's tricky. So when we look at our reports as a signal, it's often not as strong a signal as you'd like because people will they'll have a bad day or be upset with another player on the team, so they'll report them, even though that player has not done necessarily anything wrong. So what we do there is we sort of balance that with golden data sets, where we hand label a smaller set, like 1,000 examples, and we hold that out as test data so that we can see how well we're performing when we actually do it. And those look a lot better than our reports, but we're still able to use the reports as a proxy for sort of training on bad behavior.
Oh, I see.
With the mastery ranking system and the rating post games, like the S plus A system, basically, do you train that model offline and then upload it per patch, or do you do it live?
We train it offline. Currently, it's trained and then stored in S3, and then the API picks it up and scores each game.
So mine is actually short. Are you hiring right now? And the other question is, do you only hiring here in California, or in Europe you don't have any data engineering or data analyst, data scientist requirement, right?
So we are hiring. We have offices throughout the world. Most of the data science team is in LA. We do have an additional office in St. Louis where some of our data scientists are. But yeah, we're definitely hiring.
I actually have a question
Sure.
myself. I don't know if I'm allowed to ask one. Yeah, I was wondering, now that you have this big team of data scientists, what do you think are like the next big problems that you guys are going to try to tackle?
It's a good question. So there's two that are top of mind for me right now. One is we are Riot Games, even though right now we're Riot Game. We have one game. We aspire to have more games, and so there we're working very closely with designers to help them improve the game earlier with via reinforcement learning or sort of any other techniques that we can. And so there's that one, and then there's also sort of moving more towards an online world where we're actually scoring models much more, it's real time versus sort of a lot of the things we've done historically has been batch. And so we're rolling out, there's been a lot of talks at Spark talking about feature stores and sort of model stores, and we're looking at doing similar things.
Cool.
I think one
Well,
more.
if there are no other questions, let's give Wes. Oh, I'm sorry. Wait, one more question. I'm sorry.
Did you say reinforcement learning? You're using reinforcement learning to do game testing?
Yes. So the goal there is, there's been a lot of excitement in reinforcement learning for game playing, and I think it's going to be a hot topic in the next couple years, and so we're doing it to help sort of influence the design of the game, so help find what's fun and then help make sure it's balanced.
Has there been any thought in using reinforcement learning for creating game AI?
That is a follow-up to what we'll do with the balance stuff, yeah. So the idea there is that we want to be able to build agents that play at various skill levels so that we can drop them in and play the game alongside our players.
All right. Well, if there are no more questions, let's give Wes a big round of applause. Thank you.